Hello, Lana. Welcome to Manifested Online Classes. My name is James Kenyani. We are going to continue with our topic on longitude and latitude. Today we are going to look at longitude and time. Longitude and time. So the lesson is longitude and time. One would ask himself, why are we studying this? The objective. There is a great relationship between longitude and time, and it depends on how the Earth rotates. The Earth takes 24 hours to make a 360 degrees rotation. It is from there that we shall get at relationship. So the main objective is to enable the learner to get the relationship between longitude and time and use it to calculate the time differences of places on Earth. So straight to our classroom globe, the Earth as you see it would rotate from west to east. It takes 24 hours to complete one rotation of 360 degrees. So the Earth would rotate from west to east. That's why we see the sun rising from east to west. So more easterly places see the sun first. The westerly places see the sun earlier. So the westerly places see the sun later. In the easterly places, the sun sets earlier. The sun sets earlier than westerly places. So we go direct to the relationship. So Lana, the Earth rotates once in 360 degrees. One complete rotation takes 24 hours. Takes 24 hours, or 24 times 60 minutes, you get 1,440. But when it rotates, it is moving, making differences in longitude. This way we are making differences in longitude. We are dealing with the longitude. That's why time will be related to longitude. Therefore, 1 degree difference of longitude, a time difference of, isn't it? It will give a time difference of, because for in 360 degrees it rotates that. So you'll take 1,440 minutes divide by 360. We actually get 4 minutes. So if two places on Earth have a longitude difference of 1 degree, the time difference will be 4 minutes. Therefore, 1 degree difference will be equivalent to 4 minutes. 1 degree difference of longitude will give 1 degree difference of longitude will give a time difference of 4 minutes. So it's very good. Once we've known that, we can apply it in getting times differences of places on Earth. That's why we jump direct to an example. So the question comes there. We have a question on the board, Lana. The longitude of Moshi and Tanzania in Moshi in Tanzania and Lucknow in India are 38 degrees east and 81 degrees respectively. What will be the time in Lucknow when it is noon in Moshi? So straight to the solution. We have Moshi and Lucknow. So for Moshi, 38 degrees east. Lucknow, 81 degrees east. So straight to the longitude difference. Since they are both on the east, you'll just get the difference. This is more easterly. Each time will be ahead. So longitude difference will be 81 degrees. Subtract 38 degrees. 81 degrees subtract 38 degrees. So it gives a longitude difference of 43 degrees. So time difference you'll take the 43 degrees times 4 minutes. Because a time difference of 1 degree gives a longitude difference of 1 degree gives a time difference of 4 minutes. It gives a time difference of 4 minutes. So you'll come and calculate. 4 times 3, that is 2. 4 times 3, that is 2. You carry 1. 4 times 4 is 16. 16 plus 1 is 172 minutes. Converting to hours, this is equal to 2 hours, 52 minutes. 2 hours, 52 minutes. So since Lucknow is more to the east, they see the sun before Moshi. Each time will be ahead. So time in Lucknow will be ahead because it is more to the east, Lana. It is more to the east. So time in Lucknow, you'll take the time in Moshi, which is known. Time in Lucknow will be 12 noon plus 2 hours, 52 minutes. So it's 14:52 hours. If you convert to 12-hour system, it will be 2:52 p.m. We've got the time in Lucknow. It is ahead. Moshi noon, Lucknow, 2:52. So it gets darker. It gets to 9 earlier in Lucknow than Moshi. We look at the second example. So Lana, another question posed there. In example N, P and Q are two places on the equator. They are both on the equator with a longitude difference of, with longitudes, not different, longitudes 4 and 9 degrees west respectively. So 4 is for Q and 9 degrees west is for Q. So it means P is more easterly. So when you come to the solution, learner, a simple sketching will help you. So we find P is more easterly. You can write it to the right hand. And Q is here. So if you are taking the Greenwich Prime Meridian, 0, for Q it is 9 degrees west, and P, Lana, is 4 degrees east. You have to be very careful. When one is to the west and another one to the east, when you get the longitude difference, you add. When you get the longitude difference, you add. So you see, this is the prime meridian. Prime meridian, the standard of measuring longitude. So this is 0. This one is always 0 degrees. So you can see the time, the longitude difference. The total longitude difference, 9 plus 4 degrees. So longitude difference between P and Q is as shown, 9 degrees plus 4 degrees, which is 13 degrees. Straight to time difference, learner, we'll take the 13 degrees times 4 minutes for each longitude change of 1 degree. So this gives me 52 minutes. The time difference is 52 minutes. So you'll come here, which time has been given? Q. So the time here is 20 30 hours. So you reason time at P will be ahead because it is more to the east. So therefore, time at P will be, you take the time at Q, 30 hours, you add to 52 minutes. So if you add here, if I add, I'll get 82 minutes. I cannot write here 82 minutes. I'll subtract 60 and I remain with 22. I remain with 22. I carry that 1 hour. I'll get 21. So this will be 21, 22 hours. That will be the time at P. That will be the time at P. So learner, let's go to the assignment you'll do. Note how you are getting the time difference. We did this because one was to the west, another one to the east. In the first example, we just subtracted because all of them were to the east. So Lana, there goes the question. Given that A, B, C, D lie on the equator, they both lie on the equator, with A having a longitude 60 degrees west of the Greenwich Prime Meridian, B 30 degrees west of the Greenwich Prime Meridian, C 20 degrees east, and D 120 degrees east. Find the time differences in the local times between A and B. A and B. Note what I said here. If they are both on the west, you will just subtract to get the longitude difference, and you multiply by 4, which is giving a longitude difference of 1. It will give 4 minutes. So, but if you find the relationship, one will be on the west, another one is on the east, to get the longitude difference, you add Lana. So thank you very much for the audience. Go through that work, and let's meet in the next lesson. Bye-bye.